Hi class, this video is going to help with 6.3, which is minimization with a greater than. So think about it, with maximize, usually you're less than and you're in that bounded region. And with minimization, you're in that unbounded, it goes on forever, but you want what's the lowest, right? So it's a greater than situation. The next section starts to mix those up and is a little bit harder. So we'll see a problem like this, and I'm going to show you this method through an example. So if we were told to minimize the cost at $16 times x1 plus 45 times x2, and these were our subject to, okay? So maybe this is the amount of hours we're allowed, and this is maybe the material. That's the kind of problem that you're going to do this with. How am I going to start a minimization? Well, I'm going to make it a dual problem. So what I'm going to do is change it to a maximization, and then my answer will look different. You get your answer differently on this one. So follow me. Here's our first step. Is to form a matrix. Oops, I'm going to spell matrix wrong. I really wanted to put the X where the T should be. Okay, so what I mean by this is we're just going to form a matrix, and we have to do something called transpose. So the matrix has to have our objective function at the bottom, and then these two, we always have our greater than 0, we kind of ignore, right? So our matrix will go 2, 5, 50, and then 1, 3, 27, and then the objective function. And this time you want to keep it this way, but with the C on the other side, don't move everything over with the C. So it'll be 16, 45, because these were X1s, X2s, and then use a 1 for the C. Okay, this is a matrix of this problem. Then from here, I'm going to do something called transpose. And it looks like this, A to the T. I'm going to try to talk loud and at the screen so that I don't have to record this video for the 100th time. We'll see. Having lots of trouble. So, oops, I forgot the N in transpose. But transpose, it kind of looks like this symbol. And this is my second step. But basically, what we're going to do is we're going to switch our rows to our columns. It's kind of weird, but that's what we're going to do. We're going to transpose this matrix. So this row will become our first column, 2, 5, 50. Okay, the next one will go 1, 3, 27, and then 16, 45, and 1. This matrix right here will help you form this dual problem. So for our third step, we're going to form our new problem with a max. Okay. And a less than or equal to instead of greater. So it's going to look like this. Here's our first row, and we're going to use y's, which is just because we're forming a new problem. Okay, and we don't want to confuse x and y's. So it goes like this: 2y1. This is our first row. Oops, you can't see it. First row, 2y1 plus 1y2 is less than or equal to 16. So it's just that first row. 5y1 plus 3y2 is less than or equal to 45. Now, the objective function, we will now change the C to a P because we're looking for profit. Maximize profit, minimize cost. Those are what we're really looking at. So 50 y1 plus 27 y2 equals p. That's our new problem. Now we're just going to use the simplex method to solve this. But again, it's a little bit different on our solution. So let's go ahead and go to our next step. So fourth step is to use simplex. Okay, so let's use simplex to solve. So let's go ahead and write out our slack formulas or equations. Okay, so we had our first one here is going to make 2y1 plus y2, right? Plus, here's where it's a little bit different. It doesn't want you to use slack because the slack is actually our solution to the original problem. So now we add x1 as our slack. That's a little weird, but that's how we're going to do this one. Sorry, let me close. Maybe. And you could use still S1 if you wanted, but this is way once it, I lost our problem. That's why I was looking around like a mad child here. Equals 16. Okay, and then our next one would go 5y1 plus 3y2 plus x2 equals 45. And the last one is going to go 50, oh, excuse me, negative 50 y1 minus 27 y2 plus p equals 0. So we do still have to move our objective function over with the p so that they come in as a negative. Otherwise, you have no negative indicators in that denominator, and we won't get anywhere from there. So now let's go ahead and set up our initial tableau. It's going to go 2, 1, 1, 0, 0, 16. And what do these stand for? Y1, Y2, X1, X2, and P. That's why the answer is different, is our slack actually tells us our solution, which we don't look at normally. Okay, so then we have 5, 3, 0, 1, 0, 45, and we have negative 50, negative 27. I wrote that kind of weird. 0, 0, 1, 0. Okay, here's our initial tableau. Now, they like to use a straight line across the bottom to help you remember that it's a dual problem and the answer is different instead of the dotted. Okay, so where are we going to start? Well, we always start with the most negative. Okay, so our most negative is negative 50. So then we're going to look at 45 divided by 5 and 16 divided by 2. Okay, so 45 divided by 5 is 9, 16 divided by 2 is 8. So we want to go with this row here. That makes this one here our pivot. And let's go ahead and make that 2 a 1, just like we normally do. We like it to be a 1. So we're going to divide row 1 by 2. Okay, we're going to write that out. So this becomes 1, 1 half, 1 half, 0, 0, 8. Okay, second two rows stay the same. Okay, so now we want to get the zeros under our 1. So we need this to be a 0 and this to be a 0. So we're going to times by negative 5 to get this one and positive 50. So row 1 negative 5 times row 1 plus row 2, replace on row 2. Remember, we never change our row that is our pivot row. We change the other two to have 0 here, 0 here. So then 50 times row 1 plus row 3, and we'll replace that on row 3. Okay, so the first row stays the same. 1, 1/2, 1/2, 0, 0, 8. I kind of wrote big. Now I don't know if it'll fit all the way. Well, I know how to make it fit all the way. Ooh, there we go. Okay, perfect. All right, so we got to look at this part. Row 2 is going to be negative 5 times 1 plus the 5. That's going to give me 0. Negative 5 times 1/2. And you can totally cheat and use your calculator if you need, but negative 5 times 1/2 is negative 5 halves. And negative 5 halves plus 3 is 1/2. I did negative in there, right? Yep. Negative 5 times 1/2 is again negative 5 halves plus 0 is negative 5 halves. Negative 5 times 0 is 0 plus 1 is 0. 0 times plus 1 is 1. Oops. See, that's what's going to get you. One little thing. Negative 5 times 0 is 0 plus 1 is 1. Negative 5 times 0 plus 0 is 0. Negative 5 times 8 is negative 40 plus 45 is 5. Okay, last row we do 50. So 50 times 1 is 50 plus negative 50 is 0. 50 times 1/2 is 25. 25 and 27 make negative 2. 50 times 1/2 is 25. 25 plus 0 is 25. Anything times 0 plus 0 is 0. Anything times 0 is 0 plus 1 is 1. 50 times 8, I'm going to steal my calculator. Oh, yeah, 400. Didn't really need my calculator. You know, just in case. All right, so here we are. Okay, we have one more negative indicator, negative 2. Okay, so if we look, these are both positive, but what's smaller, 50 divided by 0.5 or 8 divided by 0.5? 8 divided by 0.5 is 16. 5 divided by 0.5 is 10. That makes this one our next pivot. How do we make 1/2 1? We times it by 2. So we're going to times that one by 2. And I'm going to write smaller. So 2 times row 2. Replace on row 2. So our top row is not changing. That's 1, 1/2, 1/2, 0, 0, 8. Second row is going to be times by 2. So 0, 1, negative 5, 2, 0, 10. Bottom row is staying the same. And that was our pivot. So we need the 0 there, 0 there. So let's take negative 1/2 times row 2 plus row through 1, replace on row 1. Okay, and then 2 times row 2 plus row 3, replace on row 3. So we're only changing rows 1 and 3, so the middle stays the same. 0, 1, negative 5, 2, 0, 10. Okay, so negative 1/2 times 0 is 0 plus 1, right? It's there. So negative 1/2 times 1 plus 1/2 is 0. Negative 1/2 times a negative 5 is a positive 5 halves. 5 halves plus 1/2. 5 halves plus 1/2. Isn't that 3? Yes, it is. Okay, and then negative 1/2 times 2 is -1 plus 0 is -1. Times 0 plus 0 is 0. Times 10 is going to give you what? -5 plus 8 is 3. Bottom row. 2 times 0 is 0 plus 0 is 0. So this has to stay the same, right? You don't want to lose our last pivot. 2 times this one plus this one is 0. 2 times this one is -10, so that's going to be a 15. 2 times that one's 4 plus 0 is 4. 2 times 0 is 0 plus 1 is 1. 2 times 10 is 20 plus 400 is 420. I feel like I might have made a mistake on there. Hopefully not. I don't have the answer to this one like right in front of me to know. Okay, I don't think I did. Here's where we got to look back at the solution. This is y1, y2, x1, x2, p. So here is the solution. The solution is the slack in x1 and the slack in x2. So our actual x1 is going to equal 15, our x2 is going to equal 4, and our cost is going to equal 420. And that is going to end up being your answer to the original problem. Okay. I am going to make one more video with another example separately though, so that hopefully this one will work out.